Hello, everyone, and welcome. Today we're going to be talking about predictive maintenance, answering the question, what is predictive maintenance, and getting a deeper understanding of condition-based maintenance, which is another term for predictive maintenance. So first and foremost, what is it? Predictive maintenance and condition-based maintenance are the same thing. Different terms for the same thing. Predictive maintenance, you'll hear a little bit more kind of older. I think people are trying to lean more towards condition-based maintenance because predictive maintenance gives that false impression that we're psychics, we can predict everything, which is not the case. What we do is we take readings from the machine or observe the machine in some way to figure out what the condition of the machine is and then base our maintenance activities around that condition. Same term though, same idea. Predictive maintenance, condition-based maintenance. There is a predictive element, absolutely, for people sometimes. Some people are cautious to stay away from that term. What we're doing is we're monitoring the state of the machine, so different metrics of that machine or parameters of the machine, meaning vibration, temperature, amperage, sound, oil quality, visual cues like leaks and things of that nature, ultrasound. We're using that information to evaluate the state of the equipment. So what we're doing is testing the equipment to narrow down the health of the equipment or to get a quick health check on the equipment. And if we see that the equipment is not doing well, there are hints, there are hidden things that will tell us what could be wrong with the equipment so we can direct our maintenance for those activities. Using that information, we can evaluate the state of the equipment and come up with maintenance recommendations that are suited for how the equipment is actually doing, what's actually going on with the equipment. So, predictive maintenance requires using technology and data, using technology to record data and data to foresee the potential failures in equipment before they disrupt operations. If we're being real specific, you're actually detecting faults, and your faults are little things wrong with your equipment that when left unchecked or unfixed can snowball into failures that disrupt your operations. So the industries that use predictive maintenance, there's no end to that. Manufacturing, healthcare, aviation, facility management, military, fleet management, and so much more. Whatever you can think of, I'm sure somebody is doing predictive maintenance or experimenting, researching predictive maintenance and uses in those ways. The purpose of predictive maintenance, first and foremost, is always safety. So by minimizing maintenance activities, and by minimizing not necessary maintenance activities or maintenance activities that we didn't need but don't help your equipment, having less hands-on machine and having better planned maintenance, all of those things are going to contribute to safety. The more planned our work is, the more controlled our environment is, the safer it is for us and our employees. Of course, there's also operational efficiency impacts. You're keeping your equipment up and running, and you're having better understanding of when you may need to take that equipment down so you can better plan for it and make sure you're not impacting. Let's say we're talking about manufacture. Let's say you don't want to impact the manufacturing process. Or let's say we're talking about a healthcare facility. You can get secondary systems in or backup systems in to prevent that impact to operations. And of course, all of this also comes with a cost benefit. We're doing maintenance more mindfully, and so that is going to impact our spending. We're going to spend less on unnecessary maintenance. We're going to spend less on reworking our maintenance. And of course, there's also time that comes with that. The other thing is in planning your maintenance activities out better, you're less likely to have to do expedited shipping on any spare parts or anything of that nature. So that has a big cost impact as well. So ultimately, condition-based maintenance revolves around monitoring and evaluating real-time health and performance of equipment, and using that information to guide our maintenance practices, to direct our efforts in maintenance. This all means that condition-based maintenance or predictive maintenance relies on the regular or continuous monitoring of equipment. Regular would be at a regular frequency. Continuous would be that you are always receiving data. Regular or continuous monitoring and analysis of equipment condition. We then take this data and use our data analytics to predict equipment failures, to identify those faults that could lead to failures. This allows organizations to address issues before they escalate to failures. Predictive maintenance contributes to a strategic approach to maintenance. It is part of a maintenance strategy, a strong maintenance strategy. That being said, it's my favorite part generally, is the condition-based predictive type of thing. That being said, it is part of a good maintenance strategy. It is not exclusively the only method of maintenance we should pick. If you were to try to apply predictive maintenance to all of your machinery, all of your equipment, all of your systems, you are going to be very overwhelmed and you're going to be buried by data, basically. You're going to have so much data that you can't go through it, that you can't make heads and tails of it, and it really doesn't mean anything, and now it's just noise. The way we make the most of our predictive maintenance is by using it in parallel, in conjunction with reactive maintenance and preventative maintenance. Reactive maintenance is the maintenance that most of the times, like the reliability engineering dialogue, kind of goes against reactive maintenance a lot of times when you're on like reading articles or at a conference. But reactive maintenance absolutely has a place in a good maintenance strategy. Little motors that you can replace easily, and they're not expensive, why spend all that time and money into monitoring it versus just having a spare on site? Or, if it's quick and it's easy to replace, things that don't impact your operations, why do you need predictive maintenance for that? Preventative maintenance is our more standard kind of time-based maintenance, where you change your oil every so often. After a certain amount of time or a certain amount of miles or a certain amount of etc., you do this maintenance activity. And there's a place for that as well. Here, we're focusing on predictive maintenance, so it's just one piece of the puzzle. Predictive maintenance is all about staying ahead of the curve, using real-time equipment condition data to forecast maintenance needs and better plan for them, better allocate your resources and all of that. So how does it even work? Uses sensors, uses the Internet of Things or the Industrial Internet of Things devices, so smart devices, and other monitoring tools to gather data on equipment conditions. This data is then analyzed to detect anomalies or patterns indicative of potential issues. What does that mean? We start recognizing patterns. We start recognizing that our equipment's not behaving how it normally does, or this metric all of a sudden shifted. Like all of a sudden you get a spike in your amperage and in what your motor's pulling. That's indicative of an issue. That's telling us that, okay, this is a sign that there's a condition issue, a fault in that motor, or something contributing to it. The proactive approach of predictive maintenance empowers organizations to address impending problems precisely when they're needed, eliminating the need for premature and unnecessary interventions. So let's review those types of maintenance that we just went over: reactive, preventative, and predictive. Reactive, preventative, and predictive. Reactive maintenance is responsive, responding to failures, responding to immediate issues, sometimes called firefighting, right? Maintaining in response to what is failing. Preventative maintenance is time-based maintenance, or maintaining on a schedule, maintaining on a certain frequency. Predictive maintenance is condition-based, maintaining in response to equipment condition data. which you're going to need to collect and review. Using condition-based maintenance in your strategy gives the ability to pinpoint issues based on real-time conditions, provides actionable insights needed for effective decision-making, ensures a more focused and resource-efficient maintenance approach, improves planning, which of course cuts costs and usually helps morale a little bit, and enhances overall operational efficiency, which makes your production team or your operations team a lot happier and a lot more pleasant to deal with. Of course, that's also the main goal of business is generally operations. So we're facilitating that. We're making sure we can continue to operate in the way that we need so our business can make the money that it needs to make so that we can continue to do the work that we're doing. So those benefits of predictive maintenance really add up. Safety and cost savings, minimizing unplanned downtime, reducing financial impact associated with unexpected equipment failures, extending the lifespan of equipment generally, further optimizing the initial investment that you make into that equipment and those systems, enhancing your operational efficiency by providing data-driven foundation for decision-making. One thing I didn't put on here that I think it's worth mentioning is also if you apply predictive maintenance in an inclusive way, in a mindful way where you're including everybody, it does have the ability to kind of close the gap between different departments. There is a way that you can get your operations or your manufacturing, production, etc., involved in your predictive maintenance to help kind of get that communication between maintenance and operations a little bit stronger, which will pay off. We'll just say it'll pay off. A lot of issues really stem from that fracture between departments. Predictive maintenance gives the ability to make informed choices based on real-time conditions, ensuring that resources are allocated where they're needed most, streamlining maintenance processes, and maximizing productivity. I'm not going to go too much into the Pareto principle here, but the Pareto principle is central to so much of my maintenance strategy, reliability engineering mindset. And it is the 80-20 rule that 80% of impacts come from 20% of efforts, meaning that if you allocate resources where they are needed, you can make massive impacts. That's a very brief version of it. So now what is the impact of condition-based maintenance on decision-making? It plays a pivotal role in shaping effective and informed decisions in your maintenance department. By monitoring the condition of equipment, organizations can anticipate maintenance needs, schedule interventions strategically, and prevent potential failures by addressing the faults that they come from. This shift from reactive to proactive decision-making results in a more efficient allocation of your resources, reducing both downtime and your maintenance costs. The operational excellence impacts of implementing condition-based maintenance or predictive maintenance is that organizations who are leveraging these predictive maintenance technologies or theories or activities gain a competitive edge because they're making data-driven decisions that optimize the overall operational efficiency of the maintenance department and the operations as a whole. From resource planning to production scheduling, the ability to base decisions on real-time equipment condition enables a more agile and responsive approach to all of the challenges that maintenance can throw at us. The implementation of predictive maintenance involves a combination of technology and processes, and ultimately a shift in your organizational culture, or the culture of your maintenance department, your operations department, and so on, as far as you can reach with that culture shift, right? So from a technology perspective, first recommendation that I have is to use the technology that you have, or to look into the technology that you have. Many of the plants that I've been to, they have a closet of maintenance and reliability tools. They have a closet of predictive maintenance tools. Maybe they're not calibrated, but they have a bunch of stuff that they could use that they just don't know how yet, or the person who was in charge of that has left and it kind of fell by the wayside. But a lot of times there are tools already there for you. If you do not have, like, let's say vibration meters are very expensive, and I've been to a lot of plants that have them and don't use them. Aside from that, vibration and ultrasound, I would say kind of equal in terms of probably ultrasound. More plants have like ultrasound guns, but a lot of times you'll see those things in the closet somewhere, and you're like, why aren't you using this? We don't know how, or we didn't know we had it. Aside from all of those kind of higher level tools that we tend to think about with predictive maintenance, do not underestimate the power of your BMS or EMS system. Or whatever you use, if you have a historian looking at data, whatever you have, whatever data you're collecting, you can use that to start your predictive maintenance program or your condition-based maintenance program. Research before you invest in anything. Hopefully that's why you're here. That's what you're doing. Once you are ready to invest, you are going to have to invest in some sensor technologies, or most likely you'll want to invest in some sensor technologies, data analytics tools, and robust infrastructure for real-time data collection. I would say as we kind of like go through this, it's like sensor technologies are the highest benefit there. Data analytics tool, if you have maintenance technicians or reliability engineer or predictive maintenance technicians, they can help with that element of data analytics. And then the infrastructure for real-time data collection. Real-time data collection and absolute continuous data collection is really only for a select amount of things. So we don't need to start there. We can start with what we have. So I mentioned the importance of that culture shift. The culture element of implementing predictive maintenance. Your culture shift is what's going to bring the success to that. Embrace a mindset that values data-driven decision-making and proactive maintenance. That's a core, but also empowering your staff. Training personnel to interpret condition-based data and empowering them to act on predictive insights ensures a successful implementation and sustainability of a predictive maintenance program. Get them excited. Honor what they have to say. Honor their feedback. Listen to their feedback. Feedback is data, particularly feedback from stakeholders, from your personnel. These are professionals that you hired for a reason. Empower them. Just empower them, and you'll see that their delivery changes. It's going to change. How you approach that with different employees is going to change. But ultimately, it's about respect, listening, honoring. That's the word that keeps coming to mind. Honor each of your employees, their opinions, their feedback, and so on. Challenges in predictive maintenance. The initial investment is one. So this is offset by the cost savings and increased efficiency that you'll see. With correct implementation, you will have a return on investment from that initial investment. That being said, if you want to start without that initial investment, start with tools that you have. There'll still be a little bit of investment of man hours and all that. Start with the tools that you have, and then take your savings from that and reinvest it into further improving your predictive maintenance program. Skill set and technical ability are another obstacle that we can easily work through by getting training, using resources, or working with a consultant. I'll have my information at the end if you're interested. Resistance to change within the workforce is another challenge or another obstacle you might face. And again, empowerment, yes. How can we get that empowerment? Inclusion and involvement, communication, training programs, highlighting the positive impacts on job roles. Ultimately, involve your workforce. Involve your workforce in not only the implementation, but also some of the decision making. Um, to get their involvement is going to get bigger buy-in from them. Inclusion and involvement makes people care more, right? It's something that you've invested time and energy into. So now I care. Now I want it to succeed. Work with them. Work with them to get the best results. So predictive maintenance or condition-based maintenance, we foresee potential faults and make informed decisions based on real-time equipment conditions or recently logged equipment conditions. And we shape our decision-making process based on this information. This optimizes our overall operational efficiency, bringing benefits like cost savings, increased equipment lifespan, safety, strategic advantage. And this is all coming from this data-driven decision-making, mindful maintenance, if you will. Contact us through our website or schedule a consultation. I'll have a link in the description box below so that we can do that. And that way I can help you with your predictive maintenance program. First consultation is free. And of course, like and subscribe to get more of this. We're doing a little bit of a pivot. We'll still include some of the mechanical engineering content, but we're leaning into the industrial. My professional background is maintenance and reliability, so we're trying to include some of that. So expect to see that all coming. All right. Thank you so much and have a good one.